In this video, I'm going to be explaining the properties of a 30, 60, 90 special right triangle and how we can use those properties to solve for some side lengths. So this is the most basic form of a 30, 60, 90 special right triangle. It gets its name because of its angle measurements. There's a 30-degree angle, a 60-degree angle, and a right angle measuring 90 degrees. So we have three different side lengths in this type of triangle. This could be considered a right scaling triangle because each side length is different. We have two different legs, but they're each going to be a different size. And so there's going to be a short leg and a long leg. The shorter leg is going to be across from the smaller angle. So across from the 30-degree angle is considered the shorter leg. And then across from the 60-degree angle would be considered the longer leg. Not the longest side, just the longest leg, because the hypotenuse is always the longest side, and it's always across from the right angle. So if you could label each of your sides, then we can use the following three formulas. The shorter leg is always going to be half the hypotenuse. So if the hypotenuse is 2, the short leg would be 1. Or if the hypotenuse is 2x, the short leg would be 1x. And vice versa, the hypotenuse would be double the short leg. The longer leg is always whatever the short leg length is times the square root of 3. And so we have these three formulas that we can use, and we can actually make them a little bit more fancy. Because the short leg times the square root of 3 is the long leg, we could solve for the short leg in this equation by dividing both sides by the square root of 3. And so we get the short leg is the long leg divided by the square root of 3. We could rationalize that expression, multiply top and bottom by the square root of 3, and we would get this version. So the short leg is half the hypotenuse, but it's also a third of the long leg times the square root of 3. Since we know that the short leg is half the hypotenuse, then we could substitute that into this version and say that the long leg is the short leg times the square root of 3, or the long leg is half the hypotenuse times the square root of 3. And then once more over here, we could substitute our short leg for this equation again. So the short leg is a third of the long leg times the square root of 3. So the hypotenuse, which is double the short leg, could also be double a third of the long leg times the square root of 3. So when you're first learning this, definitely focus on these top three equations and use those until you get used to them. Once you get used to those and you want a little bit more of a challenge, then you can start to use these bottom equations. But definitely use those first versions before you start to implement these bottom ones. Let's do some examples. There's really three types of questions with a 30, 60, 90 special right triangle. In our first version, we know the shorter leg or the shorter length here, in which case it makes solving for the longer leg and the hypotenuse pretty easy if you know your properties. So if I double the short leg, I get the hypotenuse. So if I double 6, my hypotenuse is 12. If I multiply my short leg by the square root of 3, I get the longer leg. So the longer leg is 6 times the square root of 3. It's not much math to do if you just know your properties for these special right triangles. The second type of problem you might see is if you know the hypotenuse. So how can we solve for the short leg and the long leg given the hypotenuse? Well, we know that the short leg is half the hypotenuse. So if the hypotenuse is 17, then the short leg must be 17 halves, or 8.5. And once we have the short leg, we could just multiply that by the square root of 3 to get the long leg. So it could be 17 halves times the square root of 3, or 8.5 times the square root of 3. However, if you didn't solve for the short leg first, there is a way to solve for the long leg given the hypotenuse. So it's one of those fancier versions of our formula. If we just take half the hypotenuse times the square root of 3, we get our long leg. Well, that's essentially what we did. We took half the hypotenuse to get the short leg, and then we multiplied it by the square root of 3 to get the long leg. So often solving for the short leg is the easier thing to do because once you have the short leg, all the other pieces kind of fall into place based on those three formulas. So a good technique is just to solve for the short leg first. Sometimes you don't need it though. once you get used to using these fancier versions right here. So one more example that you might see is, what if you're given the longer leg? This is the trickier example. So we want to find the short leg first, because then we could just double that to find the hypotenuse. So to find the short leg given the long leg, we could divide the long leg by the square root of 3, or we could use that rationalized version of this formula, the long leg divided by 3, or a third of the long leg, then times the square root of 3. So if we do that, we just substitute our long leg, take a third of it, a third of 12 is 4, and then multiply by the square root of 3 to get the short leg. And there's our short leg length. All we have to do now to get the hypotenuse is double it. So 2 times 4 times the square root of 3 is 8 times the square root of 3. If we didn't want to solve for the short leg first to find the hypotenuse, we could say that the hypotenuse is double the long leg and then divide by the square root of 3. And we could work that all through, and we would eventually end up with 8 times the square root of 3, just the same. So not just one way to do these types of problems. There is an easier way to do them, though, and it's just based on these initial 3 formulas. Just start there, substitute what you're given, and solve for what you need to know. And then once you get used to it, start to include or use these fancier versions, and it might help you do things a little bit faster. Let's do a few more examples. And let's work through the process. So the first step that we want to take is to identify the pieces of the right triangle, or label the pieces of the right triangle. So oftentimes you're only given either the 60 or the 30. You're not given both. So you have to plug in whatever angle measurement was missing. We know these two angles are complements of each other. They have to add up to 90. So if you're given 60, the other one has to be 30, or vice versa. Across from the 60 is the long leg. Across from the 30-degree angle is the short leg, and across from the right angle is always the hypotenuse. So once we have our pieces labeled correctly, then we can use our formula. Often mistakes happen when these pieces are labeled incorrectly, because it doesn't matter if you use your formulas correctly if you're plugging in the wrong values. So identify the pieces first, and then substitute what you're given and try and solve for what you need. So if we're given the long leg, we could find the short leg by taking a third of the long leg and multiplying by the square root of 3. So a third of 3 is just 1, and times the square root of 3 just gives us the square root of 3. So there's our short leg value. If we double that, we get the hypotenuse. So 2 times the square root of 3 is just 2 times the square root of 3. Over in this example, this time we're given the 30-degree angle. So assume that this down here is the 60-degree angle. So across from that must be the long leg. Across from the 30 is the short leg. And across from the right angle is the hypotenuse. So we're given the short leg. That's the easier version of these examples. Double it to get the hypotenuse. So the hypotenuse must be 4. And multiply the short leg times the square root of 3 to get the long leg. So the long leg is 2 times the square root of 3. One more example here. This time we're given the hypotenuse. That's the side across from the right angle. We're given the 30-degree angle. Across from that is the short leg. And that must mean that this missing angle down here is 60. So across from that is the long leg. So if we're given the hypotenuse, we can find the short leg by just taking half of that. So the short leg is 2. And then once we have the short leg, we can find the long leg by just multiplying by the square root of 3. So the long leg is 2 times the square root of 3. So those are the properties of a 30, 60, 90. Hopefully you can use them to take some shortcuts when solving for the lengths of each side.